Hello all, welcome to VZD Academy. This is Anil Kumar, Faculty of Digital Electronics. Sir, up to now we have seen 6 types of gates. Now let us try to understand the leftover gate, which is called as XNOR gate. Sir, this XNOR gate is also called as coincidence gate, or we can say equivalent circuit. Why we are calling with the different names? Let us try to understand. I told in the previous lecture, whenever we are learning about any type of gate, we just need to remember things are, the first one is what is its logical circuit, logic circuit, and what is the truth table, what is the truth table, and what is, we can say, logical expression, and number of inputs and outputs. And fifth one, what is control input, zero case, and what is control input, one case. And also we just need to see what is commutative law, and what is associative law, and finally we just need to learn what are the properties, of XNOR gate. These are the things which we need to learn whenever we are studying about any type of gate. Sir, the basic things which may get questions from competitive point of view, we can say that 5th to 9th point onwards we may get questions in the competitive exam point of view. Let us try to understand one by one. Sir, here logic gate of XNOR, we can say the symbol of logic gate, we can say logic gate or logic circuit also, we can say symbol of XNOR gate is like this. We have seen XOR gate. This XNOR gate is also very similar, but one bubble, extra bubble we are adding, which means one, we can say that one NOT gate we are adding to XOR gate. We can say this will become XNOR gate. Sir, here A and B is the inputs, and now we can say Y is output. This is logic circuit. And the second thing, sir, truth table for the logic gate, XNOR gate, we can say truth table is let us try to understand. Here truth table is also similar like XNOR gate. Here we have two inputs which are A and B, and Y is the output. Sir, for Y output we can say A bar, B bar plus A into B. This is what logical, we can say, equation, logical equation. Based upon this equation, let us try to draw the truth table. Here first of all I will take here A, B are the inputs, and now let me take what is A bar, and now I will also take what is B bar, and I will take A bar into B bar and AB, and finally I will take A bar, B bar plus AB, which is, we can say, Y. Now let us try to understand all these things for XNOR gate case. Sir, here we have two inputs which are A and B. The moment when I have two inputs, which means I will have four combinations. Which four combinations? I know that here 0, 0, 0, 1, 1, 0 and 1, 1. These are the four combinations. Let me try to draw the truth table. Here this is input A, and now here A bar, which means automatically everything will be complemented. Here 0 will become 1, 0 will become 1, 1 will become 0, 1 will become 0. And now for B bar, which means B will be complemented. Here 0, here 1, 1, 0, 0, 1, 1, it will become 0. And now a bar into b bar, a multiplication process, which means we need to multiply a bar into b bar. Here 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, and then 0 into 0, we can say 0. And the next step is a into b, which means we just need to multiply the inputs here. A into b, first input is 0 into 0, we can say 0. And now 0 into 1, we can say 0. And 1 into 0, we can say 0. And finally 1 into 1, here finally 1. Sir, the final step, y equal to a bar into b bar plus a into b, which means we just need to add these two conditions, a bar into b bar plus a into b, which means the moment when we add 1 plus 0, 1, 0 plus 0, 0, 0 plus 0, 0, and then 0 plus 1, 1. So this is what truth table. Sir, based upon truth table, I have an understanding that the moment when inputs, whenever both are equal, which means 0, 0 or 1, 1. Whenever the both inputs are 0, 0 or we can say 1, 1, which means whenever the both inputs are equal, the condition is a equal to b, either 0 or 1. When a equal to b, the output is here 1 and then 1. We can say output is 1. Sir, the next thing we can understand that the moment when a and b are not equal, whenever the inputs are not equal, we can say output is 0, we can say. A not equal to b, we can say output is 0. This is the thing that we need to understand, or we can say remember, sir, to solve many things. Sir, this is what truth table. And coming to third point, here logical expression, we can say third one is logical expression. Logical expression. Sir, the logical expression of XNOR gate will be like this. We have seen here at logic gate circuit, y equal to we can write as a bar into b bar plus a into b. This is what SOP, sum of products form. And now the standard logical expression for XNOR gate is y equal to a, this is what XNOR symbol, and b, a XNOR b. This is what the regular logical expression we can use to represent XNOR gate, and this is, we can say, sum of products form, a bar into b bar plus a into b. So now let us try to understand how many number of inputs and then number of outputs. Sir, let us try to understand here, similar like as we have seen the 6 gates. Now let us also try to understand from the truth table, or we can say logic gate. Here a and b are the inputs and y only one output. Fourth point, we can say number of inputs and output. We have 2 inputs and only 1 output. The fifth point is control input, 0 case. Sir, let us try to understand the fifth point, control input 0 case. Here when we apply one of the input is 0 always. Here this is called XNOR gate symbol. Sir, let us try to understand XNOR gate symbol. Here this is A, and now this input B equal to 0 always. And now here Y equal to A XNOR B is the output expression. The moment when I apply here for different cases, A equal to, let me apply 0 and 1, and let me apply X, and also let me apply some square wave. For all these 4 cases, what will happen? Sir, we know the truth table here, A and B. We have seen that whenever 0, 0, 0, 1, 1, 0, 1, 1 conditions, Y equal to A XNOR B is the logical expression, or we can say equation. Sir, we have seen that whenever we are having A equal to B, which is output 1, whenever A not equal to B, we can say output is 0 for XNOR gate, which means A and then B both are equal, we can say output 1, and A, B are equal, output 1. A, B here not equal, so we can say output is 0. Based upon this logic, we can say that equivalent circuit, which means whenever A and B both inputs are equal, then output is high, we can say, which means it is producing 1. So based upon this condition, whenever both inputs are equal, A equal to B, then output is high, which means based upon this logic we can say that this is the equivalent circuit. Sir, now let us try to solve the control input 0 case. Let us try to understand. Here the moment when we take A equal to 0 and B equal to 0, what will happen? Both inputs are 0, I can say output is 1 based upon this condition. Now first input is output is 1, and now second case, here A equal to 1, B equal to, we can say 0. Sir, the moment when both inputs are not equal, I can say output is 0. And now the third case, I can say here A equal to here X, and then B equal to, I can say 0. Sir, now let us try to understand one thing. Here B equal to 0, which means B equal to 0, then automatically what will happen? If one of the inputs is 0, from the truth table we can understand that if one of the inputs is 0, automatically the output is opposite to the, we can say, inversion of input. Here B is 0, which means output is opposite to A, input A. Here A is 0, here output is opposite to input B. Here B is 0, output is opposite to input A. So now here B is 0, which means output will become, here input is X, we can say output will become X bar. So that is the thing I just want to convince. And now fourth case, sir, here A equal to square wave, and now B equal to, we can say 0. Here also, here one of the inputs is 0, so output will become the opposite, one of the another inputs, and also we can say that another input will become inverted. We can say here this is the square wave and this will become inverted. So this is what one of the inputs 0 case, or we can say control input 0 case. Now let us try to take the second condition, or we can say here sixth condition, first condition, second, third, fourth, fifth condition over. Now let us try to understand sixth condition, that is called control input 1 case. Sir, let us see. Here the moment when I apply, one of the inputs is always 1. Here A 0, 1, X, and let me take some X, we can say square wave. Here B equal to always 1. So what will happen? Y equal to A, X nor B is the case. So based upon this truth table, let us try to understand what will happen when we apply one of the inputs is 1. One of the inputs is 1. What will happen? Let us try to see. Sir, here first case A equal to 0, B equal to 1, which means both inputs are not equal. We can say when both inputs are not equal, we can say output is 0. And now the next case A equal to 1, B equal to 1, which means when both inputs are equal, we can say output is 1. And now third case, here A equal to X, here A equal to X, which means what will happen? If one of the inputs is 1, sir, here let us try to apply logic. Here one of the inputs is 1, we can say output is exactly another input. Here one of the input B is 1, we can say output is input A. Here A is 1, we can say output is input B. Here B is 1, we can say output is input A. So this is what the understanding. So based upon this, here B equal to 1, which means output is another input, A equal to X, so we will get X. And now the moment when I change A equal to square wave, what will happen, sir? Here B equal to 1, A equal to square wave. Based upon this logic, we can say that output is another input, that is called square wave. Sir, from these two conditions, we can understand that if one of the inputs, if we keep on apply B equal to 0, or any one of the input is 0, here the circuit is acting as inverter. When we give A equal to 0, output is 1. when we give a equal to 1, output is 0. When we give a equal to x, output is x bar. When we apply square wave, the square wave will be reversed. So based upon this condition, I can say control input 0 case, the circuit is acting as inverter. And now let us try to take the next case, control input 1 case. When we apply one of the input is 1 for all conditions. So now here when we apply 0, the circuit is producing output 0. When I apply one of the inputs is 1, then circuit producing output is 1. When I apply x, output is x. When I apply square wave, output is square wave. Which means whatever I am applying at another end, we can say one of the input is, if I keep on apply 1, and another end, another input, if I can apply whatever, the output is producing same. So based upon this condition, can I say that, sir, the circuit is acting as memory element, memory circuit, and second case is the circuit is acting as buffer. Sir, these are the two conditions that we need to remember. The questions are asking in the competitive exam point of view. Our topic is commutative law. Here 7th one, commutative law. Let us try to understand commutative law. I told you in the previous class itself, the moment when we interchange inputs, here A and B, here y equal to A x nor B. This is what the logical expression, we know that. The moment when I interchange, when I apply this is B and this is A, when I interchange the logical inputs, logical circuit inputs, what will happen? This output will become y equal to B x nor A. This is the logical expression, which means if I can write both the outputs in the form of SOP, y equal to A bar B bar plus A into B. This is exactly equal to y equal to, we can say B bar A bar plus B into A. So this is exactly equal. So based upon this condition, we can say that the XNOR gate is following commutative law. Now the 8th point is associative law. Sir, 8th point is associative law. Associative law. What is the associative law? Means when we add one more input to the logical circuit, this is, we know that here A and B, y equal to A x nor B, and now if I can add one more input here C, I want to give, let me call it as y1, and if I can add one more input, this is y2 output. What will happen, sir? y2 equal to A x nor B, and then we can say x nor C. So this is what output 1. Here let me take another case. Here, sir, this is XNOR gate having inputs A, or I can say B, C. Now output will become B XNOR C. And if I can take A here, this output will connected to another XNOR gate, and now output is Y2. Here Y2 will become Y2 equal to B XNOR C of XNOR A. So this is what another logical expression. Here these two outputs, we can say these two outputs are not equal. So based upon this output, which is both the outputs are not equal, we can say that the XNOR gate is not at all following associative law. Sir, we can understand whether these logical expressions are following associative law or not based upon truth table. If you can draw a truth table for these two expressions, we can understand that these logical expressions are not following associative law. So the first property, A XNOR A equal to 1. Second property, A XNOR A bar equal to 0. And third property, I can write as A XNOR 1 equal to A, which means 1 in and then A will become out. So this is interchanging. So A XNOR 1 will become A. And the fourth property is here 0 in A, XNOR 0, and then out is A bar. And now fifth property is A XNOR B XNOR C equal to 0, whereas A XOR B XOR C equal to 1. This is what XOR gate property, this is XNOR gate property. And so based upon this, I can write as A XNOR B XNOR C equal to A XOR B XOR C whole bar. So these are the 6 properties that we need to understand to solve the problems of XNOR gate. So this is about logic gates.